All right, so to solve two-step equations, how are the next few problems different than those above? Well, they're going to have more than one step. In other words, like the different sides of the equation are going to have an expression which is typically not simplified. So in some of these, you're going to have to simplify each side before you start the solving process. So how are these different? They won't be simplified. They won't be simplified, okay? And what do we have to do before we isolate the variable is simplify each side of the equation. So we're going to put together the steps that we did, the simplifying part of it and the solving. It's just now we'll have to do both. So like if you look at number 17, it says 3m plus 5m equals 16. Right? So notice how the left-hand side is not simplified. So we need to simplify that. What is 3m plus 5m? 8m. So now that we've simplified it, we can solve it like we did a one-step equation. We can divide both sides by 8. And that gives me m equals 2. All right, so you just want to be on the lookout for having to solve it first, or simplify it first. Number 18, is there anything to simplify? This side is just a number. There's nothing to simplify there. On the right side, are these like terms? No. So in this case, like both sides are already simplified, so you can go ahead and start the solving process. So the big question is like, well, what do I do first here? I've got two things happening to my variable. It's one thing is multiplying by -4, and it's also adding 5. So how do I decide what to undo first? Well, when you have a two-step equation like this, where you have two separate things happening, you are always going to undo the addition or subtraction before undoing multiplication and division. What you're really doing is you're using the order of operations backwards because you're undoing every operation that's supposed to be done. So up here at the top, I'm going to write that down. First, undo multiplication, addition and subtraction. And then your second step will be to undo any multiplication or division. Division. Okay. So, with that in mind, what should we do first for number 18?
Subtract 5.
Yeah, good. Subtract 5 from both sides. So I'm going to say -5, -5. Notice I'm showing the step, I'm showing my action, and then I'm going to show my result, and I'm going to have to do that one more time. So that's why this is a two-step equation. So here, -15 minus 5 is -20, equals 4m. These will cancel out. 5 minus 5 is 0, so we don't need to write 0 plus 0. And now we have a two-step equation. This could have been something on your quiz from today. So I divide both sides by -4. And I get m equals 5. And if you leave the m on the right-hand side, that's not that big of a deal. Like if you just leave it 5 equals m, that's fine. I just get in the habit of always writing the variable first on that last step. All right, we're already on question 19. How about that? That went by fast. All right, here we have a two-step equation. The left-hand side, there's nothing to simplify. There's no like terms or distributive property to take care of. So we've got it down to a two-step equation. What do we need to do first? Yeah, take care of that subtraction, right? So how do I undo that minus 6? Yeah, add 6 to both sides. So I have x divided by 4 equals negative 5 plus 6 is 1. Now what do I need to do? Yeah, multiply by 4 on each side. Good. So I get x equals 4. And so we'll go through a bunch of these problems. I mean, the best way to get really good at this solving is just to keep practicing. All right, number 20. X plus 4 divided by 3 equals 6. Okay, so this one's kind of weird because you have an implied set of parentheses here. So this is going to actually switch up the order of what you do. It's going to be a little different, okay? So if you have addition or subtraction that's in the numerator of a bigger fraction, then you actually have to take care of that denominator first. So this is going to sort of like switch the rules on you already, okay? In other words, we need to get rid of this thing that's outside of the parentheses first. So we need to actually multiply both sides by 3 first. Okay, there's an implied set of parentheses. So that'll give me x plus 4 equals 18. And then we can subtract 4 from either side and get x equals 14. All right, number 21. It looks like we have some like terms here, so we can do some simplifying to sort of rewrite this. What is 5z minus 2z? 3z minus 4 equals negative 7. And now that I've simplified both sides of the equation, I have a 2-step equation I can solve. So I just go through my normal 2-step solving process. So I'm going to add 4 to both sides. Get 3z equals negative 3. And now I need to take care of that multiplication or division. In this case, the multiplication. I want to undo the multiplication with division and divide both sides by 3. So I get z equals negative 1. How are y'all feeling about this so far? Okay, all right, okay. Did y'all solve problems like these in 8th grade or no? Not these complicated. Yeah, a little bit? Okay, cool. So number 22, we do have some simplifying to do up front. We want to combine like terms. 9f minus 7f is going to be 2f. So 2f plus 4 equals 8. We subtract 4 from either side. So that gives me 2f equals 4. So what's our final answer going to be? What is f? 2. Make sure that you're showing each step and try to write it, pretty neat because you only have so much space to work in. You want to, when we're sort of proving what the variable equals, the most important thing about what you write is that it's clear, right? Like we want to make sure that what you're trying to communicate makes sense to whoever's reading it. Yeah? All right, now number 23 is a little different. What do we got going on with number 23? Got to distribute first, right? So let's take care of the distributive step. Going to multiply the -4. Okay, -4z plus 48 is 42. Then subtract 48 from both sides, yeah. And you know, I'd be using a calculator at this point, 42 minus 48, just to be careful, you know. So what is 42 minus 48? Okay, so we got -4z equals -6. And then we divide both sides by -4. Ooh, 6 divided by 4, that doesn't divide evenly, so we're gonna have to, what does it come out to be? 1.5. Okay, so there's two ways you could write this. If you just write the decimal, that's great. But you could also convert it to a fraction. And so let me show you how to do that in the calculator. Let me borrow one of y'all's calculators over here. So if you get your answer as a decimal, you'll see this okay? And let's say, like this one is probably fine to leave as a decimal because it's terminating and it's pretty short. But if you have a long decimal, maybe you can't really see what's repeating, or you just don't know. The way to convert this to a fraction is to hit the math button. It's right here. Math, and then just hit enter, enter. And then it'll convert it to a fraction for you. So you can also say that this thing equals 3/2. Either way is fine. So we are going to start, integrating fractions more often into these equations. All right, number 24. We've got a lot going on with number 24. Looks like we're going to have to combine like terms and use distributive property. But which step are you supposed to do first? Distributive property, right? So we're going to use the distributive property and then do the combining like terms afterwards. So distribute the 6. So we're going to use multiplication here. 4 plus, 6 times 7 is 42. Okay, 6 times -m would be, so minus 6m equals 4. So we do have some like terms for us to combine. 4 plus 42 would be 46. So 46 minus 6m equals 4. So this is not written like in the same order as all the other ones. When we had all the other two-step equations, we had the variable term first, and this is second. That doesn't really change how you're going to approach the problem. You're still going to try to get rid of that constant first. So if I have this positive 46 here, how can I get rid of that? Yeah, subtract 46. So just be careful about that. I'm going to subtract 46 from either side. So 4, I'm going to run out of room here, aren't I? 6m equals 4 minus 46, negative 42, good. And then divide by 6, and then I ran out of room. M equals negative 7. All right, any questions so far? Okay, so here we've got some word problems, but they shouldn't be too hard to solve. I think we could do it. Find the value of x using what you know about the sum of the interior angles of a triangle. Oh my. What is the sum? Anyone happen to know that? Yes, sir. 180. Yeah, all of these three should add up to 180. So if you didn't know that, that's okay. Like, if I were to give you a quiz with a problem like this, I would tell you what the sum of the interior angles are. That's not something you need to memorize yet. I'll let your geometry teachers deal with that. So let's go ahead and set this up, right? We've got all three of these angles should add up to 180, right? So we've got 30 plus 9x plus 30 plus x equals 180. So we have to simplify first, right? We need to get each side of the equation to be as simple as possible, which means using distributive property if that applies, or in this case, we want to combine like terms. So let's see, I've got 9x and x, and then I've got these two constants, right? So 9x plus x would be 10x. 30 plus 30? 60. And then this looks like it's going to work out pretty nicely. I mean, look at all those nice round numbers. Subtract 60 from either side. That leaves me with 10x equals 120. Yeah, and then we divide 10 on either side. Good. So x equals 12. So if x equals 12, we could use that to find the actual measures of each of the angles, right? Oh, you can't see what I'm doing here. Let's move this up. There we go. We can use that to find the measure of all the interior angles by just plugging that back into x, right? Like, so if I look back at this triangle, this is already determined, right? 30 degrees. Here we have 9 times x for this angle, so 9 times 12. What does that come out to be? 9 times 12 would be like 108. Okay, so this is 108 degrees. And then 30 plus 12 would be 42. So you could find the three angle measures once you know what x is. And that might be something that I ask you to do. So let's try one more like that. I mean, I'm just going to tell you right, straight up, there's going to be a problem like this on your test review and your test. So I want you to make sure you kind of understand the concept of how to solve this. Let's do number 26. This is also a triangle, so the sum of the interior angles should also be 180. So we've got 50 plus, and it doesn't really matter what order you do them in, x plus 20 plus x plus 10 equals 180. So we're going to combine all of our like terms, and all of our constants, to simplify the left-hand side of that equation. X plus x is 2x. We got 50 plus 20 plus 10. So that's 70, 80. Oh, these have pretty nice numbers too. These are working out pretty nicely. Yeah. Doesn't look like we're going to end up with any fractions or anything like that. So what's my first step? We got a two-step equation here. Subtract 80 from either side, good. All right, 2x equals 100. Divide both sides by 2. Good. So if x is 50, we can fill out the rest of this, yeah? We can figure out what all the angle measures are. One of the angle measures is given, it's just 50 degrees. Okay, what is this angle measure then? Yeah, 70. And then this one would have to be 60. All right, so you can find the individual angle measures once you know what x is. All right, any questions?